So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we're gonna talk about this thing. We're gonna talk about this infinite sum, guys. But before that, let's just talk about the tool that we're going to use to prove this one down, right? So basically, this is the Fourier series, and this is the summary of Fourier series, I would say. So basically, a Fourier series, and I just forgot to write something there. F of x, I'm sorry, x belongs to b. Oh, I'm sorry, a comma b for this case, right? And we'll talk about for our case. So this is a general case, right? So basically f of x can be represented as a naught over 2 plus this sum as n goes from 1 to infinity of a sub n times cosine of n pi x over l, and l is the half period actually. Well, we'll talk about that later actually here, so we'll talk about that. And plus this sum as n goes from 1 to infinity as well, b sub n, and times sine of n pi x over l. Okay, so we have some coefficients, right? A naught, a sub n, b sub n. So let's just talk about them as well. So a naught equals 1 over l times the integral from negative l to l of f of x dx, right? And a sub n is the same integral with the same factor, but with this term introduced there, like this one. Just take a look at that. And so for b sub n, everything is same. This is your a naught actually, but we have introduced this term right there. So yeah, we are done with our Fourier series, right? And L is b minus a over 2, and b and a are upper and lower bounds given respectively. So b is your upper bound and a is your lower bound, or I would say that this is quite wrong, but a b, and I should just switch up the order, something like this: lower and upper bounds. Yeah, now it sounds good. Okay, so for our case, for what we have to do is the sum as n goes from 1 to infinity of sine of 2 pi n x over n equals pi times 1 over 2 minus x. So we have to prove this down, right? And we are gonna use the Fourier series. Okay, so our function is that we have to assume here is 1 over 2 minus x, and that too from x belongs to 0 comma 1, right? So firstly, let's talk about l. So l was b minus a over 2. So 1 minus 0 over 2, which is l equals 1 over 2, right? Okay, that's cool. So now let's talk about the function. So it's a naught over 2, the Fourier series actually, plus this sum as n goes from 1 to infinity of this thing. So since our l is 1 over 2, like you have to replace this l with 1 over 2, so that's gonna be 2n pi x, right? Yeah, so 2n pi x, and we are done with this. So let me just shorten this length a little bit, and then let's talk about the second one. So it's b sub n and sine of 2 pi nx, right? Yeah. And now let's just talk about this one. So this function is an odd function. Just take a look at that. It's x, so it's an odd function, right? So we had our a naught equals 1 over l, which is 2 times integral from negative l to l, negative 1 over 2 to 1 over 2, and it was f of x, which was like x, what was that? 1 over 2 minus x, right? 1 over 2 minus x. And well, you can write these limits as 0 to 1 as well, right? Okay, dx. So basically when you just evaluate this, so that's gonna give us 0, right? Because we had some sort of negative 1 over 2 to 1 over 2 actually. So since it's the integral from negative a to a, and that to an odd function, so obviously we know that it's 0. And so for a sub n, negative 1 over 2 to 1 over 2, and your 1 over 2 minus x cosine of 2 pi nx. Just because cosine of 2 pi nx is an even function, so basically overall this function is gonna be odd, because odd times odd is gonna be even, but even times odd is gonna be odd. So that's why this is also 0. But b sub n is not, obviously. So b sub n is 2 times integral from 0 to 1 of 1 over 2 minus x, and this was sine of 2 pi nx, right? Yep. Okay, so now let's just talk about this. So let's just split this into separate integrals. So we can say 2 times integral from 0 to 1 of 1 over 2 sine of 2 pi nx and dx, and plus 2 times integral from 0 to 1 x times sine of 2 pi nx dx, right? Okay, so this 2 and this 2 cancels out successfully, and we have b sub n as well. It's just a simple integral. It's minus cosine of, I think, yeah, minus cosine of 2 pi nx over 2 pi n, and that too from 0 to 1. So yeah, it's quite easy to evaluate, right? So it's minus of cosine of 2 pi nx over 2 pi n, and from 0 to 1, right? Yeah. And basically when we talk about this one, so that's gonna be, wait a second, when you plug cosine of 2 pi nx. So but first of all, let's talk about this. Cosine of n pi is negative 1 to the n, or maybe let's talk about k pi, because n is there already introduced, so I think that's gonna be quite messy, so let's just not make that. So if we talk about, like, look, if k is even, right, and since your k here is even to n, right, so that's gonna be an x as well, so it's gonna be wait a second, minus of cosine of even, right, so that's gonna be 1, obviously 2 pi n, so 2 pi k, so basically it's 1 over 2 pi n. And if we talk about 0, so that's gonna be minus of minus, so that's gonna be plus, and cosine of 0 is 1, so it's 1 over 2 pi n, and that comes out to be 0, right? Oh, it's not yet, and we have this second integral, that is integral from 0 to 1, 2 times obviously x times sine of 2 pi nx dx. So for this integral we are just going to use our di method, right? Quite convenient, and I think I'm just going to use it 3 times in order to just get rid of any kind of integral. So differentiating x and integrating sine of 2 pi nx. So we know about the integral. It's cosine of 2 pi nx over 2 pi n, and it is 1. And again, if we further differentiate this, so that's gonna be 0, and if we integrate this, so that's gonna give us, well, the integral of cosine of x is sine of, right, so that's gonna be minus sine of 2 pi nx, and over, I think it's gonna be, wait a second, 2 pi n whole squared. Wait a second, is that true? Wait a second, let me just get through this once, and then we'll talk about this. I think everything is fine so far, because we had this factor earlier, right, and when we just integrated that, so we're gonna have another factor of this, so if you're going to multiply them, so that's gonna give us the square of this. Yeah, exactly, yeah, right. Okay, now let's just talk about this. So it's this times this, and this times this, and this is inside an integral, and successfully we would be getting rid of this one, because 0 times anything is just 0, so we're not having any kind of integral. So basically our first part is 0, we did prove it over there. So basically your b sub n is coming out to be negative x cosine of, like, I'm talking about this one, so it's negative as x cosine of 2 pi nx over 2 pi n, and we have plus sine of 2 pi nx over 2 pi n whole squared, and evaluated from 0 to 1, right? You're right. Okay, so look, sine of 2 pi n, a factor of pi, 0. Obviously sine of n pi is 0, or k pi is always 0, and sine of 0 is also 0, so we just got rid of that. And we have b sub n as, when we plug x equals 1 here, so that's gonna be minus 1. And oh wait a second, did I have some negative in front? Wait a second, did I messed up anywhere? I'm just looking for that. I think cosine of, oh wait a second, did I have some sort of I just messed up here. It's negative 2. I'm so sorry guys, it's negative because minus x and this minus and this, yeah, I hope you're getting that. So we are just having some sort of negative 2 here, and that's gonna be a negative 2 in front, so I just forgot that factor. I'm sorry about that. Let me just fix this anyways. So it's negative 2. Okay, so we are having negative 1, and 2 pi cosine of even is just 1, so yeah, and it's negative 2 actually, because we had a factor. Oh wait a second, negative 2 times 1, negative 1 over 2 pi n. So this negative and 2 cancels out, and successfully we are having b sub n as 1 over pi n. And now let's just get back to our Fourier series, which was f of x equals a0 over 2 plus this sum as n goes from 1 to infinity of a sub n cosine of 2 pi nx plus this sum as n goes from 1 to infinity of b sub n sine of 2 pi nx, right? So basically it's 1 over 2 minus x equals a0 was 0, this is 0, this is 0 as well, and we are having this sum, this sine term, sum, and b sub n was sine of 2 pi nx over pi n, and we can factor the pi from the right hand side, so that's gonna give us, and multiplying pi both sides, so that's gonna give us pi times 1 over 2 minus x equals the sum as n goes from 1 to infinity of sine of 2 pi nx over n. So yeah, hence proved guys. That wasn't difficult, but the thing that you need to have a proper information about the Fourier series, and I hope you just got that in from this video. Again guys, if you got to learn something from this video, just make sure to like, subscribe and share, and just stay tuned for the next video guys. And again, if you have any doubts so far, you are free to ask me in the comment section. I'll be there to reply your questions. Goodbye guys, take care, love you, and just learn mathematics. Goodbye guys.